Hi everyone, I am Masum Coleman, who member Group 9. Now I am going to present our project of theory of structure 1. Our group consists of 6 members who me, Alperen, Meli, Muhammed, Davut and Furkan. I just present technical view of our drawing. After me, my friends will continue. I hope you enjoy while watching this presentation. Let's start. And you see drawing as 3D. Finally, I want to show the whole drawing on AutoCAD. You see front view and right view, 8 meters, and this is right view. Chunk span is 4 meters, and finally I want to show you 3D view. Okay, I rotate and you see what is our project. See, and rotate. This is our project. Thanks for watching and listening.
Hi everyone, I will talk a bit about free body diagram, which is the second part of the project. The free body diagram of the system we designed is as shown in the figure. At the bottom, the columns are connected to the floor with a built-in support. Thus, the object will have a resistance to the movement. In the connection between the column and beams, a pin on one side and a roller supports on the other are used. Considering the loads to which the object is exposed, there is a leave load of 1.7 kN per square meter on the roof. There is a man weight of 1.1 kN. This load affects the floor. And finally, the dead load of the slab acts on the beams.
Hello everyone, my name is Ahmet Melih Terzi. I will also tell you about the forces acting on the roof of the building we have created and the diagrams created by these forces. First of all, I showed you the loads carried by the primary and secondary beams of the building and the reaction forces created by these loads. That is the loads, live loads acting, and that is the dead loads acting on beam. These are the reaction forces, and the length of the beam is shown here, 4 meters, 8 meters. In the report, diameter was written next to the forces, but since we found the diameter later, this is the figure that the diameter was included in the calculations. On this slide, I showed the shear force and the bending moment diagrams of these reaction forces. As we can see, the bending moment is maximum at the midpoint of the beam. Shear force is maxed out at the start and end of the beam. That's bending moment diagram and shear force diagram for primary and secondary roof beams. And finally, on the slide, I showed you the normal shear and moment diagrams that affect columns. As you can see, the normal forces acted on the column, while shear and moment had no effect on the columns. That's the column and the other column. It's the column normal force acting, shear force, and the moment acting on the column.
Hello everyone, I'm Mohamed Şimşek and I'm going to talk about floor primary beam and floor secondary beam. First, we determined which is the first and second beam, and then we showed the forces applied to the beams by driving a free body diagram. We had a human weight of the 1.1 kilonewtons and the weight of the flooring. We have not yet calculated the wood radii, but we need to calculate the weight of the flooring. We have drawn a force diagram with the data we have and examined what is the force diagram. The NYM diagram is graphical representation of the internal force acting on a structural element. It is used to determine the strength and stability of the element under various load conditions. The diagram is named after the three types of internal force that are represented on it: normal force, shear force, and bending moment. You can see the floor secondary beam, and we determine the first and second beam and draw the first diagrams of the second beam again. Then the force diagram for a slab shows the distribution of these internal force along the length of the slab. The normal force is the force perpendicular to the slab. The shear force is the force parallel to slab, and the bending moment is the turning effect on the forces on the slab. Thank you.
Hello everyone. Today I want to share with you the calculations of the floor and floor's design. A tree house made of oak wood with a short span of 4 meters and a long span of 8 meters. I think use of oak wood gives the tree house a natural and rustic aesthetic, while the 4 meter and 8 meter spans create an interesting and dynamic silhouette. But it's not just about the way it looks. The oak wood is also strong and durable, ensuring that the tree house will stand the test of time. We put a lot of thoughts into the design of this tree house, and it shows from the careful attention to structural details. Every aspect has been thoughtfully considered. We used a method called double integration to calculate the radius needed to support the tree house and took into account dead loads, gear load, and man weight. Overall, this treehouse is a true work of art, combining form and a function in a truly remarkable way. Thank you.
Hello, my name is Furkan, and I'm gonna talk about the deflection today. There is a formula of the deflection. It's EI times second integrative of the equals to minus m. Secondary beam of roof midpoint deflection. We use this formula over here and we find this solution 0.0444. Radius of secondary beam roof. We use the same formula over here too, and we find this solution 0.74499. Primary beam roof of midpoint deflection. We use this formula here too, and we find this solution 0.022222. And there is a radius of primary beam roof. We use the formula over here, and we find this solution x equals to 0.48599. Thanks for listening. That's all for me.